So today we're going to continue to talk more about graphing sine and cosine graphs. Now if you remember, both sine and cosine, they look exactly the same. The only difference is where they start. They still do the same pattern, middle top, middle bottom, middle top, middle bottom. The question is, where does it start? And yesterday, I hope you investigated it a little bit. I hope you learned a little bit. We already talked about what A and K do in this big long general equation. Just a quick review. A dictates what the amplitude is, and it talks about the orientation. Sometimes it might flip the parent sine graph or parent cosine graph. Rather than starting at the top, if the leading coefficient is negative, it may have to start at the bottom. We'll get into that as we keep going here. But then the other thing that we talked about was K. K is the vertical shift. And what that means, it translates the graph either up or down. It's straight up the way you think. If it's plus, it's going to move up. If it's minus, it's going to go down. But one thing that I hope you experimented with and you learned a little bit was about B and H here. B is going to change the period. And the way that it's going to do that, our default period is 2 pi, right? However, if there's a B, but so far our B has only been 1. If B is anything other than 1, it's going to change our period. And the way that it's going to change the period is going to be 2 pi divided by B. That's how we are going to calculate what the new period is. That's the worst B ever. Oh my goodness. 2 pi divided by B is how we're going to determine what the new period is. And then H is going to be the horizontal shift or the lateral shift. Horizontal shift. Now, remember, that one is the opposite of what you think. That's why I'm putting an asterisk there. Remember, plus, you think it goes right? Nah, it goes left. If it's minus, you think it goes left? Nah, it goes right. Horizontal shift. Now, horizontal and lateral are the same thing. I use them interchangeably. Horizontal and lateral shift mean the same thing. So there's the thing. We have our 4 different variables of how it's going to take our parent graph and either stretch it, shrink it, or translate it, move it. Let's get into it. Here comes our first one. Y is equal to 3 sine of 2x. Now, our period is normally 2 pi. But like we said, it's going to be 2 pi divided by whatever B is. Well, in this case, what is B? B is 2. So in this case, it's going to be 2 pi divided by 2. What is 2 pi divided by 2? 1 pi. The interval. This is a new thing too. The interval, up until today, it's always been 2 pi, right? And then the period was 2 pi. The interval was pi halves. Well, the way that we're going to find the period, and I think we mentioned this briefly on the first day, is interval is going to be period divided by 4. There's 4 tick marks that we make on these lines, right? So period divided by 4, so in this case, pi divided by 4 is pi fourths. All right, we'll come back to more about that in a minute. Amplitude. What is the amplitude here? A talks about the amplitude, so the amplitude is 3. There is no horizontal shift or vertical shift. Make a line or a none or just something that shows that you considered it. But in this case, there's no shifting to do. Okay, let's graph this. We're going to make 4 tick marks. And spoiler alert, all these graphs are going to look exactly the same. Even different than the ones from, or even though the period is different than what happened on Monday, it's still going to be the same graph. And the reason why is because we're going to scale. We're just going to change the scale is all. Let's get to it. All right, so we made these 4 tick marks. How are we going to label these tick marks? Well, our interval is going by pi fourths. That means we start at 0. This is going to be pi fourths. This is 1 pi fourth, right? So what's the next one? Well, if that was 0, 1 pi fourths, this is 2 pi fourths, which is pi halves. 3 pi fourths. And the last one is 4 pi fourths, which is pi. Hey, y'all, a little trick. Your 4th tick mark should always be your period. That's kind of your checkpoint. If you're counting by pi fourths, you should end on the fourth tick mark at whatever your period is. Yeah, so there's that. Okay, since there were no shifts, we took care of these. Since there were no shifts, our origin is still going to stay here at the origin. You remember this? Sure. So that's still staying there. However, the amplitude is 3, which means that 1, 2, 3. Our graph is going to stretch 3 units up from the origin. I'm going to make my kindergarten paper. That's my top line. The origin is going to contain our midline, is what this is called. And I'm going to go 3 units down. This is our bottom line. So I made our kindergarten paper, right? This is where our graph is going to exist. This is our top line, our midline, our bottom line. So we did our period by doing the scale. We did our shifts by where our origin is. And now we're doing the amplitude, which is how many units from the origin, top and bottom. There it is there. Right? Great. So now we graph the line. Our graph is going to exist inside of here. Since this is sine, the question is, where does sine start? Well, if you need to, remember our unit circle, I was going to start at 0 degrees, right? And this is the point 1, 0. Sine, is this x or y? Sine is y. So sine is going to start at 0, 0. But then our next tick mark, as we go around the circle, is going up. Our leading coefficient is positive, so that's going to remain the same. We're going to go up. We're going to hit our tip-top point. So the next tick mark is going to be our tip-top point. So middle, top, middle, bottom, middle. There's our graph. Smith, that looks exactly the same as the other graph, but our scale is different. You're absolutely right. And I'm going to explain this. You might not be able to get it by just me explaining this in this video, but tomorrow we'll pull out decimals or your calculator and I'll show you what's actually happening here. We're taking the sine of x. Whatever the angle is, we would do our trig thing and figure out what's up. But we're doubling the angle each time, which means that we are actually going around the unit circle twice as fast. So what used to take us 2 pi to do 1 lap, because we're going twice as fast, we're going to do 2 cycles in the same time that it took to do 1. And so there's pi. We did a full circle. If we were to go to 2 pi, we would get 2 full cycles done by the end of 2 pi. I'll show you tomorrow. Maybe you know what I'm talking about from yesterday, the investigation thing, but if not, we'll get you through it. Don't worry about it. Anyways, let's finish our curve here. So we got top, middle, bottom, middle, top, middle. There's the other cycle. So the blue is one cycle. This purple is another cycle the other way. But it would just keep doing this pattern forever and ever and ever. So there's our graph. Let's do another one, right? Are you freaking out? Don't be freaking out. It's going to be okay. I added this +1 because hopefully you've got a +1 on your worksheet. If I forgot to fix it, put a +1 on there because, yeah, it's going to be fun. All right, period. Our period is 2 pi divided by b. Now the question is, what is b here? This looks different. That's a. This is b. You might need a hint on what is b here. It says x divided by 3. So is it 3? No, it'd be 3 times x if it was 3. This is x divided by 3. Here's a hint. There's a 1 in front of that x. Some of you might know what it is. If you're still not sure, let's rewrite this another way. Y is equal to -2 times the cosine of what times x is the same thing as x divided by 3? 1/3 times x and then +1. You with me on that so far? X divided by 3 is the same thing as 1/3 x. So that means that b is 1/3. So what is 2 pi divided by 1/3? That's right, 6 pi. If you don't know how I got 6 pi, pull out your calculator and put in 2. Don't put pi in, you'll get a gross decimal. Put 2 divided by, and then make sure you put parentheses around that fraction 1/3. But 2 divided by 1/3, you multiply by the reciprocal of the denominator, you get 6 pi. Great! Our interval is whatever the period is, the period divided by 4. So what is 6 pi divided by 4? Well, 6/4 is the same thing as 3 pi halves. Some of you might be getting nervous because how are you going to count by that? Don't worry about it. I'm going to get you through it. We're going to do it. What's the amplitude? The amplitude, hopefully somebody said -2 and somebody next to him said, no, remember it's always positive. Yes, that's right. It is always positive. So the amplitude is 2. All right, horizontal shift. Is this +1? Is that an H or is that a K? That is a K. So there's not a horizontal shift. If there was, it would be in parentheses. There's no parentheses here. This +1 is outside, so that means that we're going to translate it up 1. Okay, let's get to it. The first thing that we're going to do, 4 tick marks on either side. And remember, I want you to label... Oh, my goodness, those aren't evenly spaced at all. Remember, I want you to label the positive axes. I want to know what your scale is so we can see. So, starting at 0, and our interval is by 3 pi halves. So that means we're going to count by 3 pi halves. If you're freaking out by that, think of it as 3 pi halves. We're going to count by 3 pi halves. So, 0, this is 3 pi halves. What's next? 6 pi halves. What is 6 pi halves? That's the same thing as 3 pi. You with me on that? Alright, so 0, 3 pi halves, 6 pi halves. 9 pi halves is next. What's the last one? 0, 3, 6, 9, 12 pi halves. 12 pi halves is 6 pi. Remember, y'all, period should be your 4th one. That's your checkpoint. Even though it's a weird fraction, you're just going to count by the numerator and just think of it as whatever the rest of it is. 3 pi halves. So 3 pi halves, 6 pi halves, 9 pi halves, 12 pi halves. There it is. Anywho, let's get back here. So we did our period in interval. We're going to do that first. Next thing we're going to do is the shifts. Let's do our shifts. There was no horizontal shift. However, it did move up 1. So, what that means is this is our new origin. Our new origin is up here at 0, 1. Now, I'm going to make my midline go through that origin. That's our new midline. But that brings us to our amplitude. Our amplitude is 2, which means from our midline, we're going to go 2 units up and we're going to go 2 units down. So our top line is 2 units up from our origin, 2 up, and 2 down is going to be our bottom line. There's our kindergarten paper. That's where our graph is going to exist. Alright, so we took care of all of this. All of our info here is done. Now we need to graph it. Now we're talking about cosine. And again, unit circle. If you think about the unit circle, this is the point 1, 0. So cosine normally starts at the top. Right, at 1, we're going to think of it at the top. However, because a is -2, instead of starting at the top, it's going to start at the bottom. Remember that negative is going to reflect it across the midline. So we're going to start here at the bottom. Hey y'all, finish the graph. Hopefully by now you know the pattern. If it starts at the bottom, middle, top, middle, bottom. Then go the other way. Yeah, that's my bell. That's not your bell. You don't get to leave yet, if you could hear that. Anyway, so your graph should look something like this. Hey guys, here's what's happening. We're taking our equation. We're getting all this information. Do the period and interval first by labeling our axes. Then do our shifts, figure out where our new origin is, and then you do the amplitude, you make your kindergarten paper. Word. So there's where we change the period. We change the period. Let's go on to page 2, and this time we're going to change the lateral or the horizontal shift. All right, period. In this case, period is 2 pi divided by b. What is b here? Well, there's nothing here, so what is here? There's a 1 there, so it's 2 pi divided by 1. Our period is 2 pi. Our interval is the period divided by 4, so that's going to be pi halves. Amplitude. What is A here? What number is here? There's a 1 there, so our amplitude is 1. Horizontal shift, we got one this time. This is going to go pi halves, which direction? Pi halves right. Opposite of what you think, right? Minus, so it's going to go in a positive direction. And this time there is no vertical shift. All right, so label your axes. Ready, go. All right, if you need to pause it, go ahead and pause it while you catch up, but hopefully you're here. So, we did our period and interval. Check, check. What's next? Our shift. Now, our shift went pi halves right. So, pi halves right means normally our origin is here, but our origin is going to shift pi halves right. So, this is our new origin here. On pi halves, that's the new origin. Alright, so we did those now. So our origin is going to have our midline, but then our amplitude, we're going to go 1 up above and 1 below. Smith, how come your 1 is so big this time? Well, here's the thing. I mean, we don't have to go back here. I had to go 3, so I made little ones. This one, I can scale it however I want. This is America. I can make my scale as big as I want or as small as I want. I'm a grown man. I'll do whatever I want with my scales. Sorry, let's get back to this. All right. Our new origin is here. We got our kindergarten paper. All right, so where are we going to start? This is a sine graph. Where does sine start? Sine, again, if you need to, unit circle. This is the 0.10 right here. So sine starts at 0. So this is going to start at 0. It's positive sine, so am I going to go up or am I going to go down from our middle? We're going to go up because A is positive. So middle top, middle bottom. I ran out the tick marks. So even though this is not a complete cycle here, right? I'd have to get up to here again to make a complete cycle. I'm going to stop because I'm out of tick marks. You could put a tick mark here and keep going, but here's the thing. I got 5 more tick marks here. Let's just continue the pattern on this side of our new origin. So I'm going to start from here. Bottom, middle, top, middle, bottom, middle, top, middle, bottom. There's our graph again. We're just following the pattern. Guys, the graphs are always going to look the same. The only thing that's changing is the scale. And if you want to investigate on decimals, or I'll show you tomorrow exactly what's happening here in relation to a parent graph. But that's all it is. Okay, let's go through this one. Now, if you notice here, this one looks a little bit different than our standard graph. The difference is, look at yours and look at the top of your paper. I typed this in there. How is B different from our general equation and what's happening here? Hopefully you came up with that B is outside. There's actually a parenthesis here, right? This is not a typo though. I didn't make a typo. This is the way that it should be. So here's the thing. We're going to rewrite this. Instead of writing it the way it is here, it's going to be y is equal to 3 times the sine. Let's pull out the 1/2. Parentheses. So we're going to undistribute. We're going to pull out a common factor of 1/2. 1/2, and then this is going to be x plus what is going to be left here? Well, pi divided by 1/2 is 2 pi and then minus 1. If you're not sure how I did that, again, take pi divided by 1/2. Or think about this. If you were to distribute it back, 1/2 times what will give you pi? Hopefully you see that as 2 pi. So here's the thing. We're going to use this equation. If you are ever given where b is inside the parentheses, get it outside. And then we'll work from there. So using this, go ahead and press pause and come up with your information here. Okay, so hopefully you came up with something like that. Period is 4 pi. Divided by 4, our interval is pi. The amplitude is 3. All that. So go ahead and label our axes. Again, if I'm going too fast, press pause. The interval's easy this time, right? Just count by pi's. Alright, so our period and interval, check, check. Horizontal, let's talk about our shifts. Our shifts, it's moving 2 pi left and down 1. So I'm going to make a tick mark, the one here. So I'm going to talk about what's happening. Our new origin, we're going 2 pi left. 2 pi left is 2 tick marks, 1, 2, and it went down 1. So this is our new origin right here. Our new origin is 2 pi left and 1 tick mark down. And that is our new midline, our new axes. Alright, so we got our horizontal and vertical shifts done. Created our new origin. Only thing we got left is our amplitude. Now the amplitude is 1, 2, 3 units up from the new origin. 1, 2, 3. So there's our new top line. But we're also going 1, 2, 3 down. That's our new bottom line. Alright, so hopefully you see where that is all coming from. Tell you what, press pause again. Make your graph. Think about where sine starts and where it's all going to go. And then we'll see if you're right. Go ahead and press pause. Great! Hopefully you came up with something like... Hopefully you got dots like this. Since this is sine, it's going to start here at 0 at the origin. And it's positive, so it's going to go up, middle, bottom, middle, top, middle. So, and then going the other way, your graph should look something like... something like that. Yeah? So, this is 2 complete cycles. Our start point was from here. It's a regular sine graph. We follow the pattern. Middle, top, middle, bottom, middle, top, middle. So on and so far. And work it out. Hey y'all, the homework is worksheet 8. All 3 of the worksheets are going to be due on Friday, which is the day of our quiz. If you got any questions, stop by the resource, come by, see me in the morning. Smith out!